see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby, have a taste. All the highs and the lows, no you'll never be the same. I don't really wanna hurt you, but I can't control the pain. If you're sticking by my side, maybe we could be okay. Okay, maybe you could be the change I need today. I promise that I've never felt this way. I really hope that you will choose to stay through all the pain.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. And guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away. As you fade away.
Already mic testing. Okay, perfect. Let me go to my main camera. Already we're live, and as you guys can tell by title and thumbnail, today I'm going to be working with, let's say, more machine learning. Actually, more math than machine learning under the subcategory of Scikit-Learning, where last stream I did work with, let's say, regressions and also decision trees, and a little bit, actually a whole lot of random forest, which I did not really complete last stream, so I will be working on that this stream as well. That said, let's go to my gameplay screen. There we go. Okay, oh, and I forgot to exit this. There we go. And yeah, this is Claude's brand new chat, and let me say something like, since I am live, exclamation. Okay, and then let's go ahead and send it. And I will be following a 25 to 5 minutes Pomodoro timer here, starting in 3, 2, 1, and go. And yeah, every 25 minutes, I will be getting a 15 minutes, let's say, break as well. That's it, alright, let's go. Day 78. It's actually day 79. I forgot to explicitly say, Claude, that it was day 79. That said, day 79, you got through bootstrapping. Yeah, I did work with bootstrapping last stream as well. The hard way, got your own wrong turns twice before landing on sampling with replacement. That's not luck, that's the instinct. Building today. We finish. Okay, today we finished the job. And hold on, let me on my desktop audio real quick as well. And make sure that I can hear myself properly. Is this clearer? Or is that better? I think both are the same, to be honest. I'm just gonna exit that. Quick recap of where the story stands. Trick 1, bootstrapping stops the freezing from seeing identical data, but bootstrapping alone has a hole if temp is the single most obvious, most dominant feature in the data set. Okay, that does make sense. Then almost every bootstrap sample still has temp in it, and almost every tree independently picks temp at the root anyways. Different data, same first decision. You landed with the 100 students, one obvious clue analogy, no coordination needed. They're all just spot the same obvious thing. Okay, they all just spot the same obvious thing. There we go. Okay, so trick 2 shows up. At each split, the tree isn't allowed to look at all 10 features. It only gets a random subset, say 3 of them, to those to choose from that at the split. Okay, hold up. Here's the payoff. If a tree is sitting at a split, okay, today I made the most soggiest oats actually. If a tree is sitting at a split and its normally dominant feature, temp did not make it into that random subset of 3, what does the tree do? Walk me through your reasoning. What choice is it actually forced into? Okay, let's see. If a tree is sitting at a split and its normally dominant feature is temp did not make it into that random subset of 3, it does not let's say pick the temp, and that it goes with, let's say something like it goes with whatever is the second best guess, which is the best choice for the tree. Okay, let me say something like that said. And yeah, I will be touch typing as well. That said, I just let's say something like I just started streaming, and let's say something like did not work much or at all with this topic at all off stream. This topic off stream. Let's go with something like therefore I am not warmed up yet. Okay, yeah, it takes my brain let's say a couple of minutes of review to actually get back get back on game, if that makes sense. Okay, and I'm just gonna check everything because today I am trying a different way of streaming. Actually, alongside my video, I want my stream, let's say, to let me go with my webcam. There we go. Okay, alongside my actual video, I want my stream to be able to record it as well simultaneously, which saves me a lot of time as opposed to downloading my video before I really edit it. Hold on. I'm just fixing my vertical recordings this camera because I am not streaming vertically. There we go. Okay, yeah, I think that's no. I need to go a bit more lower, right? How does that look? There we go. Okay, that looks something good. Then I'm just gonna extend this from here and then hit OK. Alright. I think that's good. Yeah, you guys cannot really see what I'm working on right now, but I'm almost done. Okay, there we go. Alright, that's perfect, because I am actually recording myself vertically and horizontally. It's more convenient to actually get short form content with that. That said, fair warning taken, and that's the right thing to flag. Not a bad thing to admit. Not warmed up does not mean wrong though. So let's check what you said. You're right, and you found the actual mechanism, not a fake. Through real reasoning. Temp is in the subset, so the tree can't use it even if it wants to. It's forced to pick the best split it can find among the 3 features it actually has available. Not second best in some abstract ranking sense, best available. That distinction matters. Hold on to it. You're right, and you found the actual mechanism. Oh, okay, not a fake. True. Real reasoning. Temp isn't the subset, so the tree can't use it even if it wants to. It's forced to pick the best split it can find amongst the 3 features it actually has available. Not second best in some abstract ranking sense, best available. Okay, that makes sense. That distinction matters. Hold on to it. Now, here's why that one forced moment matters for the whole forest, not just one tree. The tree just made its root split on something that isn't temperature, maybe humidity, maybe wind speed. Some other tree in some other split will have temp available and will use it. But this tree was forced to discover, hey, humidity actually splits the data pretty well too. Multiply that across hundreds of trees, each hitting different random subsets at different splits. Question for you. If every tree only ever used temp, no trick, what would that do to the diversity of the forest? Even though trick 1 already gave every tree different bootstrapped data. There we go. Okay, hold on. Okay, so trick 2 shows up each split the trees and allowed to look at all 10 features. It only gets a random subset, say 3, okay. Wait, hold on, let me say something like, sensei, my mind has not warmed up yet. To be honest. Therefore, let's say, is there something that we can, let's say, do in order to warm it up? I cannot focus on the readings, on understanding what I read. There we go. That's one reason I'm eating oats and cinnamon. Good for memory. Real talk, not sensor intensity for a second. That's a legit thing to name, and naming it instead of pushing through foggy is exactly the right monitoring instinct that made bootstrapping click last session. Good flagging it instead of forcing a guess. Let's not warm up on the hard new material. Let's warm up on something you already know. There we go. A quick low stakes recall rep gets the brain back in gear without the pressure of new concepts. Okay, question, pure recall, nothing new. In your own words, what was bootstrapping again? Why did sampling with replacement beat two ideas you tried and rejected? Non-overlapping splits and reordering the same rows, okay? Bootstrapping is basically when a tree picks random data from a data set in order to fill it in order to fill its placeholders, in order to fill its placeholders. For example, let's say something like 10. That said, after it does that, it asks certain questions, and based on the results, it makes a best choice. Actually, it provides a best answer. Okay, let's go with something like furthermore. Okay, furthermore, let's say something like, in order to be sure that the answer was not biased, we use multiple trees, or actually not use, we have multiple trees perform the same step again and the same step and average the answers in order to get the best answer. There we go. Oh god, that actually helped. That helped me. Whatchamacallit, warm my mind up. Good, the gears are turning, and most of that is solid. Let's sharpen it rather than move on. Because two pieces are blurring together that you actually kept separate on day 78. You're mixing bootstrapping, how each tree gets its data, with averaging across trees. Why we use many trees? Both true, but they're two different tricks answering two different problems. Let's isolate just the first one. Just bootstrapping. Nothing else. You have a data of, let's say, 10 rows. One tree needs its own training set. What does bootstrapping actually do to build that tree's data set? And specifically, what did sampling with replacement beat just handing the tree a random, non-overlapping slice of the original 10 rows? That second half, the with replacement part, is where the real mechanism lives. Take your time, don't rush. Hold on, just bootstrapping. You know what? I think I know what's messing with me. I need to drink some water. Yeah, because it may not look like it. I slept really late last night, so today I did wake up really late. I'm still partly sleepy. Okay, just bootstrapping, nothing else. You have a data set of, say, 10 rows. One tree needs its own training set. What does bootstrapping actually do to build the tree's data set? It picks random, or it picks, let's say, data arbitrarily. And specifically, why did sampling with replacement beat just handing the tree a random non-overlapping slice. Okay. It picks data randomly as opposed to us picking what it let's say gets. Okay, and then let's just send it. Oh god, this is getting a little bit tricky. That's true, but it's not specific. I'm asking about what you're describing. Let's rebuild it concretely. Say your dataset has 10 rows numbered 1 through 10. Option A, what you rejected tree gets a random slice, say 257. Just three rows, each one used once, no repeats, and it's a smaller set than the original. Option B, bootstrapping with replacement. Tree draws 10 times, each time picking randomly for all 10 original rows. And after each draw, the row gets back into the pool so it could get picked again. So you might end up with something like 22577779142. Still 10 rows total, but some repeated, some missing entirely. Question, what's the difference about the size of the dataset, option A versus option B? Option A is deprived of data, while option B consists of a lot of data to work with. Even if there is an overlap. There we go, and then let's just go ahead and send it. There it is, that's the exact distinction, and you just rebuilt it from scratch after saying you weren't warmed up. Okay, I'm slowly getting warmed up. That's the muscle working on, not fog. Option A smaller pool starved. Fewer rows means weaker signal, easier for the tree to grab into noise instead of real pattern. Option B, still full-sized, 10 draws, 10 original rows, even though some rows repeat and some get left out entirely because the size stays full. The real signal in the data generally survives even with that overlap / omission. The quantity preserved versus quantity lost distinction you earned the hard way last session. That does make sense. You're back warmed up. Okay, I finally feel warmed up actually, because you know when your mind is not warmed up, it feels like kind of stiff and like you feel like you're in a cognitive lockdown. That said, so let's return to where we actually stopped trick 2. I finally understand what I'm reading, what the hell? Okay, you already nailed the mechanism a minute ago. If temp isn't the random subset available at split, the tree is forced to use the best available feature instead, not temp, something like humidity. Here's the follow-up I asked. Word sitting with row. That's your warm. If every tree only ever had temp available, no trick 2, what would that do to how different the trees in forest actually are? Even though trick 1 already gave each tree different bootstrap data. Okay, if every tree only ever had temp available, what would that do to how different the tree is in the forest? How different the trees in the forest actually are? They would be the same, even though trick 1 already gave the trees in the forest would have the same data. Careful, that's not right, and it's worth catching. Why it's not right? Because it mixes up the two tricks. Trick 1, bootstrapping, already happened. Each tree does have different data, different bootstrap samples like we just rebuilt. That part isn't in question here. The question is about trick 2 specifically. If temp were always available at every split for every tree, no random feature restriction, what happens even though each tree already has a different bootstrapped data? Think back to 100 students. Obvious clue analogy, you nailed that one solo. Same idea. If temp is the most obvious useful feature in the data set and every tree can always see it and always choose it at the root, what do most of the trees end up doing at that first split, even with different bootstrap datas underneath them? They pick the most obvious choice. That has to be the actual case, right? Alright, I overcooked my oats. What the hell? That was the hardest thing to eat. Yes, exactly. Most trees independently coverage on a temp at the root because it's the most obvious useful feature and nothing is stopping them from grabbing it even though their underlying bootstrap data is different. So here's the real cost. Even with different data, trick 1, the tree starts looking structurally similar. Same first decision, same shape of tree over and over, and a forest full of near identical trees does not give you much benefit from averaging. Remember the darts analogy? Averaging only helps when the individual throws are making different kinds of mistakes. If every thrower is missing the same way, average doesn't cancel anything out. Oh yeah, that makes sense. That's the whole trick to patches. By randomly hiding temp from some splits, you force variety. Trees are pushed to discover and rely on other decent features. Humidity, wind speed, whatever. Not just the one obvious winner every time. Now putting it together in one sentence, trick 1 gives the trees data, trick 2 gives the trees different what? Different options to choose from. Okay, so trick one, trees start looking structurally similar. Same first decision, okay, but oh, I see. Okay, so trick 1 gives the trees the similar decision, which is the best option and the most common option that they would choose because there's no reason not to choose. But in case they did not really get that data, they move on to the second best option, which is trick 2. There we go. Huh. Close, but let's tighten an option to choose from. Is the mechanism. Okay, I was correct. Not the quiet outcome we're naming. Trick 2 restricts the options. Sure. What does that restriction actually produce in the trees themselves? Think about it this way. Trick 1, different data, different trees in terms of what rows they saw. Trick 2, restricted options at each split, different trees in terms of what? What ends up different about the tree's actual structure, their splits, their shape because of trick 2? Their structure is different because the data that they chose was the second was the available choice as opposed to the best choice. And yeah, hold up, let me fix my typos real quick. Is the available choice as opposed to the best choice. This is going to be the structure. Now about their splits and their shape. Their splits, let's go with something like furthermore, their splits and shapes would be different due to the same reason as well. Okay, and then let's just go ahead and send it. You're circling it. The reason... Okay, I'm so close to actually getting this. The reasoning is right underneath, just tangled in the wording. Let's untangle it. You said the data they choose was available choice as opposed to the best choice, but remember, trick 2 isn't about data at all. That's trick 1's job. Trick 2 only restricts which features are visible at split. The data underneath is already fixed by bootstrapping. So let's say it clearly, cleaner. Because different trees get different random feature subsets at their splits, Some trees are forced to split on humidity, others on wind speed, others get temp when it happens to be available. Finish the sentence in one clean line. Trick 1 gives trees different data. Trick 2 gives trees different features. Okay, feature wouldn't make sense. Let me not guess this. Hold up. If trick 1 gives trees different data, which could be random, which could be the first available option, the second available option, the trick 2 gives trees variety. Different trees, random, this thing. Forced to split on humidity when it happens to be available. Variety and options when they happen to be available. There we go. I think this is literally the smartest option. There it is. Okay, finally. Trick 1, different data. Trick 2, different features available at each split. And the difference in available features is what forces diverse splits. Different trees end up structurally different, not just when different rows. That's the missing piece together. Trick 1, bootstrapping, different data per tree. Trick 2, random feature subsets, different features considered per split. Both tricks combined equal to trees that are genuinely different from each other, not just superficially different. That's why averaging their votes actually cancels out noises instead of just averaging a bunch of near identical guesses. I'm going to read the question once our brain is over. That's it. Hands off anything that is not distracting. Let's go to Wuthering Waves. Hi Vivek. What is bootstrapping exactly? Basically, bootstrapping is the way we give random trees data in order for them to, let's say, figure out the best guess. The best guess is later given to us, and we do stuff with the best guess.
An unwavering faith will resonate with like-minded souls.
I did stop here yesterday. I had to enter the tunnel. I'm gonna get my timer here. And guys, how does my visuals look? I sort of fixed my visuals for Wuthering Wave just so it looks a bit more clear. Like, does it look sharper actually? I think it sort of does. But for the time being, we're gonna enter the tunnel. That was the worst way to enter it. Okay, so enter the tunnel, enter the Forgivial Pagoda, which is restart. I want to continue. Hell yeah, we're gonna continue. I'm not gonna restart my whole progress. Okay, and yeah, I gave a really general overview of bootstrapping, but I will give a better one once the timer is over. That said, resonance beacon. I have to talk to this guy, right?
That guard over there. Time for a little performance.
Oh, we did this. We watched this part.
him
I'm just gonna skip
plainly,
this because we actually watched this last stream. Next up, close the village gate to prevent exile attacks. I thought that my progress was saved. Okay, it was sort of saved. I think this was like one thing. I want to sort of ride. Oh, I can't? Okay, this is the new
This
part.
is all working a little too smoothly. I should check on the villagers first.
Talk to the elder, talk to the young people. Let's talk
The
to the
right
elder.
momentum.
Alright, I guess we're talking to the young people first.
I could do a better job than those so-called gods.
This is less talking, more like eavesdropping.
Yeah, show 'em, boss.
Now is not the time to add to their worries.
Okay, where did I talk? I just mostly eavesdrop. And this is apparently the old man.
The beacon is still down. What's happening beyond the walls right now?
Don't worry, it's just a few bandits. They're no match for our guards.
I hope so.
Open the
Alright,
gates.
that's what I call communicating.
That voice.
Okay, we gotta open the village gate.
The patrol has returned.
Talk to the guards.
Are the children all in the shelter?
Yes. You must be the one who warned him. Thanks to you both. We intercepted those exiles before they reached the gates.
He was supposed to find you. How did this...
Oh
He
god,
ran
I skipped a
straight into those
mistake. My
brigands.
fingers clicked
sound
it.
of the
She
struggle
said, how
is
did
what
this
alerted
happen?
us.
He ran straight into those brigands. The sound of the struggle was what alerted us.
If it wasn't for both of you, the situation could have been far worse.
No, it can't be. There has to be another way.
Alright, so use the refuelant hourglass. Am I gonna like revive him or like resurrect him or
One
something?
more time.
I still didn't understand, what is the hourglass about? He
Can't
had like a
let that
whole
man risk his
storyline.
life this time.
Okay, so talk to the trainee guard.
Stop right there! Don't come any closer! The beacon is damaged. Only technicians are allowed near it. Anyone else could get hurt.
I can't tell him the truth.
Let's just say we're a technician.
Are you the only guard on duty?
No, the seniors are out on patrol. I'm watching
Hello,
the
you're
village in
hiding
their
the
stead.
DJ Krypton, is that how I pronounce your name? I appreciate you joining the stream.
I see. In that case, could you let me out for a moment? A child in the village told me she lost her pet fox. I promised her I'd help her find it.
Oh.
Fox? Children these days certainly have strange tastes in pets.
Alright, that's it. That's time. Hands up anything that is distracting. Moving on. Back to work. Get back to work, y'all. There we go. I want to kind of know what's going to happen, but after we're done with this. That's it. I was going to read the question, right? So, question. Connected to the name? Connected to the name now. Given that both tricks inject randomness into how each tree is built, why do you think this technique is called a random forest and not just bootstrapped forest? Which only describes trick 1. Because the word, let's say, random. Should I say conveys? Not conveys. May also be interpreted as, let's say, variety. Okay, I'll just send that maybe. That's a reasonable instinct, but it's landing on the wrong layer. Random isn't standing in the variety as a synonym. Let's ground it in what actually happens mechanically, not what the word could loosely mean. Two different random processes are baked into building this forest. You already named both of them today. Trick 1, random sampling of rows, which is bootstrapping. That probably answered that question as well. Trick 2, random subset of features at each split. Direct question. If the technique were only named after trick 1, bootstrapping, what would it be called? It would be probably called bootstrapping trees. And given that there are actually 2 random ingredients, not 1, what does random forest fit better than bootstrap? Why does random forest fit better than bootstrapping forest? Because bootstrapping implies giving data to the trees. However, random suggests, let's say, giving random data to the trees. Okay, I think that should do the trick, right? Let's slow down. You're still collapsing trick 2 back into data. That's the exact seam. I've never heard that word. We need to close before moving on. Say it out loud with me. Feature by feature, bootstrapping equals to random rows. Data covers trick 1 only. Random forest needs to cover trick 1 and trick 2. If random forest only meant random data, it would be describing the same thing as bootstrapped forest, just a different name for one trick. That can't be the reason it's called something different. Straight question, no wrapping. Trick 2, random feature subsets. Each split has nothing to do with which row/data the tree got. So what is random over if not data? Huh, interesting. Let's think. Hold up. These oats are the most overcooked things that I've eaten. This is the worst thing. Trick 2, random subsets at each split. So trick 1 was in charge of giving data to the trees. Trick 2 was in charge of, let's say, having the trees have features to choose from. Trick 2 was in charge of having a variety of best guesses, or the variety of best available guesses that the trees could choose from. However, what I cannot wrap my head around, is the fact that is the naming question. How does the name random forest, let's say, okay, how does the two tricks, how do the two tricks together make the name random forest make sense, question mark? And then I'm just gonna go ahead and fix a quick little typo here, and yeah, ignore my punctuation for that. I was trying to phrase up there. Good naming what you can't wrap your head around. Instead of faking past it, let's stop dancing around the naming question and just answer it directly, plainly, no more circling. Bootstrap forest would be an accurate name if it were only one random ingredient, a random rose. But there are two random ingredients, that's it. One of them is the random rose, the other is the random available choices that they can pick from. Okay, but there are two ingredients baked into this forest. Random rose, random features at each split. There we go. Bootstrap forest only advertises number 1. It says nothing about number 2. Nothing about the fact that which feature a tree is allowed to look at gets randomized to. So calling it bootstrap forest would be technically incomplete. It hides the half of the randomness that actually happens. Random forest is the border. More honest name, because random does not point at a row specifically or feature specifically. It's the umbrella covering both random injections at once. Two different places, two different times in the processes, once when building each tree's data set, again and again at every single split, both driven by randomness. The name has to be general enough to cover both, so it just says random. That's it, that's the whole naming logic. Not random means a variety, abstractly, but literally. Two separate random mechanisms, so the name needs a word broad enough to cover both. A random, cover both, and random is that word. I see, okay, that makes sense. Does that land now, or is there anything specific that feels shaky? Ah, I see. It makes sense now. However, the word split here is something that I did not understand. There we go, because usually the split, when I think about split, I remember from the split method in Python, because when I think about split, it reminds me, I think that's a comma splice. It reminds me of the dot split method from Python. And then let's go ahead and send it. All right, let's see. Good catch flagging the exact word. That's the right move instead of nodding along. Totally different meaning from dot split. No relation. Let's ground it in something you already know called decision trees, which you already fully covered before random forest. Remember how a decision tree works? If it asks yes/no or threshold question at each point, like is temp greater than 75, and sends data left or right based on that answer. Question in a decision tree. Do we call that moment where the tree asks a question and divides the data into branches based on the answer? Wait, hold up. Where the... Okay, what do we call that moment where the tree asks a question and divides the data into two branches? Okay, you already learned this term. Okay, I know it. Hold up. What do we call that moment? Wait, hold on. Where the tree asks a question and divides the data into two branches. Okay, I know it. However, I cannot remember the... Oh my god, are you kidding me? REMEMBER. Remember the word for it. It was when we used the dot fit method. Okay, here's the thing. The reason I don't really remember the wording for it is, again, because this is an exposure to machine learning, which I will be working on later on in the upcoming phases as well. So I'm not working or focusing on mastery right now. I'm just trying to get a grasp of it. Good distinction. The method you called in the training hole, that's not the word I'm asking for. I'm asking about the structure conceptually, not a method name. Picture the actual tree structure. Think of an upside down tree diagram. At the very top is the root, then the tree asks a question like is temp greater than 75, and based on yes/no, the data branches into two paths. That branching port where one path becomes two paths based on a question, what is that point called in a tree? You know what? I think I gotta grab Visual Studio Code for this. Decision tree classifier is the same word you use if you were describing the literal trees is divided into. Okay. Decision tree classifier. Not quite. That's the last name. Okay, the tool you import to build the whole tree. I'm asking about one specific point. I don't understand what point though. Okay, inside the tree is the structure, not the tool that builds it. Let's go even more concrete. Anyway, away from code entirely. Picture a real tree upside down. Roots at the top, the trunk starts. At some point, it divides into two branches. Okay? Then further down, each branch might divide again into two more branches. That single point where one path becomes two paths. What do you call that point on a real physical tree? A split? Yes, that's it. A split, the exact point where the tree asks a question is temp greater than 75. One path divides into two based on the answer. That's literally what it's called. The decision trees. Oh, I see. Same word, no relationship to dot split in Python at all. Genuinely two unrelated meanings. Oh, okay. So now go back and reread trick 2 with that word properly. At each split, only a random subset of features is made available. Okay, so basically the tree split and we have two random subsets of features available where the tree can pick one of those things. Say it back to me in your own words. Okay, so at a split, we have two subsets of options, of features that the tree can pick from. And it does pay, and it picks its best answer. Close, but one part slightly off. Let's fix it precisely because... Well, let's fix it precisely because the exact number matters here. It's not two subsets. It's one random subset at each split 3 features out of the full 10. And the tree picks its best available option within that one subset, not two subsets to choose between. One restricted pool, the best choice within that pool. Try again, one clean sentence. At each split, what does the tree get? And what does it do with it? Okay, at each split, the tree gets one random subset, and it, let's say, 2 pools, restricted pool, What does it do with it? And it uses it in order to produce a best answer with the resources, with the data that it had available. There we go. I think that makes sense, right? That's it, locked in. At each split, the tree gets one random subset of features and it picks the best split it can find from the available pool, and not the globally best feature, just the one that's allowed to see right now. That's the full mechanism, both tricks fully assembled. At each split, the tree gets one random subset and it uses it in order to produce a best answer with the data that it had available. Perfect. I think I need to eat something else now. Okay, I think a minute of microwaving the oats is all I need. I put it for a minute 30 seconds. It's the driest thing ever. Okay, trick 1, bootstrapping. Bootstrapping basically is each tree trains on a different random sample of rows. Random feature subset. At every single split, the tree only sees a random slice of the features, forcing it to sometimes rely on non-obvious features instead of always grabbing the exact same dominant one. Together, genuinely diverse trees averaging their votes actually cancels out the noise. That's why it's called a random forest, not a bootstrap forest. So bootstrapping is basically giving a tree or giving a decision tree data to work with. And at every split, it moves on to trick 2, which grabs the only available, let's say, subset that it can from the options that it's got, and it makes the best guess using the available resources that it currently has access to, or the available data that it currently has access to. You rebuild that whole chain today even after saying you weren't warmed up. Okay, I'm warmed up. That recall on bootstrapping did exactly what it needed to. We're at a natural checkpoint. Want to push to random forest classifiers code. I want to push. I can push because it has not been that long. Okay, and then let's just send it. Okay, good, let's ride the momentum. Before I hand you anything, have you used random forest classifiers from Scikit-Learn before? Even briefly, you've already used decision tree classifiers, so I want to know if the random forest classifier itself is a new syntax. It is a new syntax. I have syntax, and that I have never used it. Guys, I so love touch typing. It feels like the more I freaking touch type, the better I get at it the very next day. Good flagging that clearly. That's exactly the right move, so I don't assume. Since you already know decision tree classifier, cold random forest classifier is going to feel almost identical in how you use it. Same dot fit, same dot predict, same shape. The new part is generally the new part is really just the class name and a couple of new parameters that controls the 2 tricks we just built. Here's the core syntax. Okay, so it's going to feel almost identical. Same dot fit, same dot predict, same general shape. The new part is just the class name and a couple of new parameters. Okay, that makes sense because we give random forests more data as opposed to decision trees, or they have access to much more data and much more variety of data. Okay, from Scikit-Learn.ensemble, is that how you pronounce it? SEMBL, yeah, I think that's ensemble. I want to import random forest classifier. God, these import statements are gonna, whatchamacallit, confuse the frick out of me later, because there's one which is sklearn.linear_model, or from sklearn.linear_model. I want to go ahead and let's say import linear_regression function or logistic_regression function, and from sklearn.decision tree, I want to go ahead and import decision tree classifier. And now from sklearn.ensemble, I want to import random forest classifier. Okay, but that aside, we create a models as variable and we set that variable equal to random forest classifiers, this function that we imported here, which requires 3 parameters. The first is n_estimators, that is going to be equal to 100. I'm assuming that's the 100 guesses that we're going to take with having 100 trees together. Max_features equals to squirt, which is basically square root. And then random_state is going to be equal to 42. And then we go with model.fit. Now, here's the thing. Fit is basically, you can't really have it for any, you can't give a specific definition for it, besides that it only trains your model based on the function that it's using. If I were to use fit for, let's say, logistic regressions, not logistic, linear regressions, it, yeah, I forgot, logistic or linear. Yeah, if I were to use the fit method for linear regressions, it would use gradient descent in order to give me an output. But since I'm using it for random forest classifier, it's going to give me a whole different thing, which is going to be the train models. Oh god. And then we create a predictions variable that is going to be equal to model.predict. I want to predict something. X test. Oh. Okay, notice it's imported from sklearn.ensemble, not sklearn.tree. Worth clocking that since decision tree classifier lives in sklearn.tree. 2 new parameters worth naming before you touch code. n_estimators, how many trees are in the forest. Predicted that, didn't I? And then max_features, how many features are randomly available at each split. This is literally trick 2. The mechanism we just spent this whole session on. Why is it set to squirt though? Prediction question before you run anything. If n_estimators equals to 100 and max_features equals to squirt on a data set with, let's say, 9 total features, roughly how many features do you think each split gets to randomly choose from? Even the word squirt. I'm pretty sure the square root of 9. What is the square root of 9? Can my regular calculator do that? Is there a squirt option here? 9? Square root? Okay, square root of 9 is 3. So it gets, okay, so the trees will have access to 3 features per split, because per split, since the square root ROT of 9 is equal to 3. And then I'm just gonna go ahead and let's say send it. Correct and instant. Square root of 9 is 3. Each split randomly draws 3 of the 9 features to choose from. That's max_features equals to squirt in action. That exact mechanism you spend this whole session earning. Now, sitting right there as a parameter. Your turn to write the code. Here's the ask. Using whatever data set you've already got set up from decision trees or a similar one, build and train a random forest classifier with n underscore estimators equals to 100. Max underscore features equal to squirt, and random underscore state equals to 42. With the prediction, okay, wait, one question. Let's say something like one question before I work on the code. What does random underscore state equals to 42 parameter, let's say do? What does it do? Good question to ask before running instead of blah blah blah. You've actually seen this one before back in decision trees and probably even train/test splits. Do you remember what random underscore state controlled there? I do not. Take a guess on that. What do you think state is referring to when something is described as a random? Give the trees access to random data. However, does the 42 there mean that we have a total of, let's say, 42 datas available, question mark? And then I'm just gonna fix this to does the 42 and send it real quick. I had 2 typos. Because there's nothing called datas, it needs to be data. Good question attempt, but let's correct both pieces. This one's actually simpler than you're making it. Random underscore state has nothing to do with how much data or which specific split mechanism that max feature and bootstrapping. Alright guys, that's time. Hands off anything that is not distracting.
Just
Moving
you
on.
alone?
Gonna grab this a bit here. There we go.
It's all right. I'm a resonator. I can look after myself. I'll only be searching the area nearby. It won't take long.
If you insist. Just make sure to return before nightfall.
Alright. Okay, so go outside the village to track down the exiles. Can I? Yeah, man, I can't use my motorbike. The motorbike is so
Phew.
freaking cool, but the
I
worst
think
thing
you
is...
got it.
But the
The
worst
rest
thing
is
is
up
that...
to me now.
Okay, the way she thinks to her mind the whole time, she feels like a manipulator. But also, the
This
bike is so
time,
cool, but it's
I
hard to
should be
control
able to
it.
keep everyone safe.
Alright, let's go. Oh wow, do I got a fight? Can I use her abilities?
I could use another dancer.
Ooh, I want to use her art. Oh wow. Oh wait, she's actually taking. I'm actually taking damage. What the hell?
Stop hiding!
Who's hiding? I wanna.
Come now.
Wow.
I could use another dancer.
Guys, watch your ultimate.
Clouds fade. Clarity remains.
Stop!
Okay, you guys can't tell me that stuff wasn't me. Let me see that again. Let me see that again. Is that a combo? Is that a combo?
I could use another dancer.
Wait, it's a 2v. It's a 4v1. Watch out. Oh, did I get back up? I was ambushed. Oh, a shiver runs down my spine, giving me goosebumps. That did not rhyme. Wait, is that? Is it the moon
Fatal
fox?
malice. It strikes the moment when you are least on guard.
It's the moon fox. I didn't know she could come here.
When you cannot count the blades hidden in the dark, there is no single answer to this test.
She's still. I forgot she was under a test.
Someone must stand in this position, whether it's you or that soldier. Someone must be sacrificed. This prison of fate represents that burden.
Represents that burden.
If one life could settle this, I would not ask for two. Surely you understand.
Wow, she's huge.
No, I don't.
Man, I love the fan.
Child, are you feigning ignorance?
How can I possibly understand if you don't explain it to me from the beginning? Besides, I'm still here, alive and kicking.
If I had not intervened just now, you would have already died.
Yeah, whatchamacallit, I'd second that.
Yes, I have you. I have you, therefore I can take the risk. I can try to overturn an outcome that's already been decided.
Yo, Hiding Observer, appreciate you joining the stream. Wow, the
Reality is
intimidation.
not like the questions I set. It has no gaps for you to slip through.
He's mad.
What you
No,
are
not a
attempting is
cutscene, not a
nothing more
cutscene.
than desperate gamble.
Okay, it says drag slowly to the left or right following the arrow. I'm not gonna do that because I have like 25 seconds on clock and I know for a fact that I'm gonna be left on a cliffhanger and that I would have to miss some of the story. So I'm gonna go ahead and, let's say, eat some oats here to waste some time. And that's time. Hands up anything that is distracting. Moving on, back to work. We're gonna see that cutscene our next break. I'm so excited to see what's gonna happen. I forgot that it was a freaking test all along. That's it, break now. Oh god, guys. There was a break, but I did not want to continue there. Okay, that said, good guess attempt. Random state. Okay, where was I? I was here, right? Random underscore state has nothing to do with how much data or which specific split mechanism. That's max underscore features and bootstrapping, which we already covered. It's about something totally different. Reproductibility. There we go. It's about something totally different. Here's the problem it solves. Every time you run code with randomness... Wait, was my desktop audio on? Oh, please tell me it was on. Okay, it was on. There we go. Here's the real problem it solves. Every time you run a code with randomness in it, like pickling bootstrap samples or pickling random feature subsets, you normally get a different random result each run. Different trees, different accuracy every single time you hit run. Random underscore state equal to 42 is just a seed. It locks the randomness to that. Every time you just run the code, you get exactly same random choices in that same exact order. Okay, it's just a seed. It locks randomness so that every time you run code, you get exactly that same random choice. Oh. In the exact same order, same results every run instead of a new random result each time. And the number 42 itself, it's not a count of anything, not 42 rows, not 42 trees, nothing like that. It's arbitrary. You could write random underscore state equals to 1, random underscore state equals to 7, or random underscore state equals to 999, and it would work identically. It would just lock in a different but still fixed sequence of random choices. Question check. If your friend runs the exact same code with random underscore state 42, would they get the exact same accuracy number as you or a different one? Let's say something like they would get the exact same number as me. And then I'm gonna send it. So if I run it, random seed equals to 1. So if I run it at that value, I get the same result. Apparently, yeah. Hey, what is your tech roadmap for learning? Actually, if you guys do want access to my roadmap, you guys can, let's say, join my Discord server and either go to the Coding Helps Us chat, the general chat, or the Python chat. Mention my name there, asking me for the roadmap. I will be personally DMing it to you guys after the stream is over though, and you guys can get access to my roadmap. Hold up. Let me just go here. There we go. And you guys can get access to my roadmap through the link in my description. Right somewhere. Yeah, there we go. Through the link in my description. Through my, let's say, bio. There we go. Or by typing exclamation Discord on chat. All lowercase, no space. A link should pop up within, let's say, 3 to 4 seconds. You gotta ask it in chat, in the chat of Discord. That does make sense. That's it, exactly right. Same seed equals to same locked in. A random sequence equals to identical results every time on any chain. That's the whole point of setting it. Reproducibility. Not data size, not tree count. Now you're clear on all three pieces of that constructor line. Back to the task. Prediction before you write code. Do you think random forest's accuracy will be higher, lower, or about the same as the single decision tree you already trained on the same data? Why tie it back to what we're building today? You think random forest accuracy will be higher, lower, or about the same as the single decision tree? It would be the same as the single decision tree. Okay, you already trained because we are using the same random sample every time. Therefore, hold up, I made a typo in every time. Therefore, every tree, therefore all 100 trees, let's go with all 100 trees, would, let's say, end up with the same exact result. Okay, and then I'm just gonna go ahead and send it after I fix my typo for every time. Depends. I see. Okay, hold on, that's a real misunderstanding and it's worth catching now before you run the code. Okay, random 42 does not mean every tree gets the same sample. Let's untangle this for what you already know. Random underscore state equals to 42 locks the sequence of random choices, but it's still a sequence, meaning each of the 100 trees gets a different random raw. One after another following that locked sequence. Wait, so it's like a lock does not mean every tree gets the same sample. Let's untangle what you already know. So it's a locked sequence. Following a lock sequence is like shuffling a deck with a fixed shuffle pattern. You still deal 100 different hands. They're just the same 100 different hands every time you run the code. So tree number 1 gets bootstrap sample A, tree 2 gets bootstrap sample B, C, etc, etc. All different from each other, and every time you rerun the code, you get the exact same ABC sequence again. Oh, I see. Reproducible, but not identical across trees. Oh, I see. Re-ask with that corrected. Given the 100 trees, do I still get different bootstrap data? And different random feature subsets? Just in a reproducible locked sequence, do you think the random forest accuracy will be higher, lower, about the same? Okay, so, the accuracy will be different from any single decision tree. However, every time we run the code, we will end up getting, let's say, the same exact result. Even though every tree will have different subsets. There we go. And then I'm gonna go ahead and send it. And every time I messed up again there. You've got the reproducibility piece locked in perfectly. That part's exact, but step side of the actual question. I didn't ask whether the result would be the same across reruns. You already nailed that. I asked compared to a single decision tree, the accuracy. Decision compared to a single tree's decision accuracy. Will the random forest accuracy be higher, lower, or about the same? Oh, I see. It would be higher because it will have more data to work with and cut noises. There we go. Noises. Close on the conclusion, slightly off on the why. We're tightening for, okay, it's not really about having more data. Remember, each tree in the forest actually gets bootstrap samples as roughly the same size as what the single decision tree would train on. Are the tree's full training set? That forest isn't winning because any one tree sees more rows. It wins because of what you nailed with the darts analogy earlier. One tree can overfit the noise in its particular data and make a confidently wrong call. But when you average the votes for 100 different trees, different data via trick 1, different features via trick 2, their individual mistakes tend to be a different direction, so they cancel out and the average vote lands closer to the true pattern. One sentence fix, it's higher not because of more data but because of more patterns. There we go. And then I'm gonna go and eat some oats. Getting closer. Okay, more pattern is a bit vague. Let's nail the precise word. You already used it earlier today unprompted and it was exactly the right thing. Think back to the darts analogy itself. 3 shaky throws, each missing in different direction, but when you average their rows, the misses cancels out. What do we call that quality? A tree making different kinds of mistakes instead of all making the same mistake. You named the umbrella concept behind the whole reason trick 1 and trick 2 exist. One word, what is it? Wait a minute. What do we call that quality? Tree making different kinds of mistakes instead of all making the same mistake. I remember the umbrella concept, I can't remember the freaking word. Trees making different kinds of mistakes. Trees making different kinds of mistakes. There's an umbrella. I know this. I literally remember this part. I can't remember the word. Hold up. Trees making different kinds of mistakes instead of all making the same mistake. What's this called? Okay, let me think. Hold up. I forgot the word for it. I do know what you mean because I remember the umbrella analogy. Okay, let's send it. Hold on. This is it's not hard or confusing. Wait a damn minute. No shame in blanking the word. You clearly still love the concept. You just need the label reattached. Let's rebuild it from the analogy itself. 3 throwers, each missing in different directions, not all missing the same way. That quality of not all doing the same thing, not all making the same mistake in everyday English. If I said trees are different from each other in how they make mistakes, what single word would you use to describe it? It's a word you'd also use to describe a team with mixed different skill sets or a stock portfolio with a mix of different investments. Random. Random is the mechanism, not the quality. Variety starts with a D. Think of the hint again, a team with mixed difference skill sets, a portfolio with a mixed different investments. What's the word for made up of different varied elements instead of all the same elements? Starts with a D. What starts with a D here? Depends. Diversity? I don't want to say it now because I didn't say that. The word I'm asking for equals to the result of that randomness. The fact that the trees end up different from each other. Someone from my chat told me diversity. Is that correct? Oh, it feels kind of bad if it's correct. Yes, diversity is exactly the word. Oh no, I couldn't think of it. Oh god. Okay, well that's fine. I guess I'll remember it now. Okay, good on our chat for backing you up and good on you for checking rather than just taking at face value. Diversity. Trees that are genuinely different from each other, making... Trees are different from each other, making different kinds of mistakes, so when you average their votes, the mistakes cancels out instead of stacking up. That's the whole payoff. Full picture, trick 1 bootstrapping, trick 2 random feature subset. Combined diversity, mistakes cancel when averaged, higher accuracy than single tree. Okay, now go write your code. Well, you said variety, which is close enough. I see. Okay, but it still feels kind of bad. But then at least I understand it now. So I think that whatchamacallit makes up for it. Okay, so I'm gonna go ahead and read the code. Okay, here's the thing with the code. I'm gonna go with this. Control A, Control C. I'm gonna grep plot here. Okay, about the code. You said that I should use the current contents that I did have. I did not understand what you meant. Okay, and then I'm just gonna go ahead and send it. Okay, good. Catch flagging the conclusion instead of guessing. That saved us from you writing the wrong thing. What you pasted is your old decision tree code. That's a decision tree classifier, not a random forest classifier. That's fine as a reference, but not the task. Here's what I actually meant. Use the same dataset, same x and y, weather/temp data. Both swap in new class and new parameters we just covered. So concretely, the task is change the import from sk.ensemble, import random forest classifiers, keep your same x and y data. Create a model as random forest data classifier n_estimator equals 100, fit and predict. All right. So apparently I'm gonna go ahead and let's say create a new Python file in that case. Gonna just delete all this stuff. There we go. So apparently under my Scikit-Learn, I'm gonna go ahead and let's say create another Python file called random tree classifier.py. Alright, CLSSIFIER. Okay, now in my random tree classifier.py, I'm firstly going to go with Control A, Control C, copy that. Paste this here just because I want to keep my data set. Nope, not going to paste it here. Okay, I'm going to go with something like from Scikit-Learn. Was it Scikit-Learn? L-E-R-N. Okay, from Scikit-Learn.ensemble. Ensemble sounds more like assemble. E-N-S-E-M-B-L-E. I want to go ahead and import random tree classifier. Okay, and then after the random tree classifier, I'm gonna go ahead and let's say this time copy my x and y data sets. And then we're gonna go ahead and let's say paste it here. And then we're gonna go ahead and create a model. Model is gonna be equal to my random tree classifier function. And then after I'm done with that, I'm gonna go with something like model dot the fit method in order to train my model. This method is going to be requiring x as a parameter and y as a parameter, my two data subsets. And then I'm gonna go with something like prediction, which is going to be equal to my model. It's gonna be equal to, I don't want to say print statement. I'm just gonna go with something like my model dot predict. Okay, now about the prediction, I don't know what do I predict. Okay, what is this? Where is the gaming stream? The game is gonna be on after 6 minutes and 22 seconds when I will be having another short break. That said, let me go back to Claude's instructions. I don't really know what to add for my freaking, let's say, model.predict. What predict should I add? I don't know what to add for my prediction though. And also, was it ensemble? E-N-S-E-M-B-L-E. I think I spelled it correct. E-N-S-E-M-B-L-E. There we go. What do I add for my predict though? I don't know. Let's go with Control A, Control C. Copy that. I'm gonna grab Claude here, paste it, and then say something like, then say, I do not know what to add for my predict. I often struggle to add, let's say, parameters there. Okay, that said, I forgot to add parameters for my random forest classifier as this function. Okay, so I'm gonna go ahead and use a reference to actually add my parameters here because I did not really remember the parameters that goes in here. Hold on. There we go. Okay, so apparently for my random tree classifier, I'm gonna be adding a parameter of n_estimator. How do you spell it? E-S-T-I-M-A-T-O-R-S. E-S-T-I-M-A-T-O-R-S. So my estimators is going to be equal to 100, and then I'm gonna go with something like max features. Max_features. Okay, which allows my tree to have access to a certain number of features that I tell it to have access to. My feature is going to be squirt. Okay, because SQRT, because I want the square root of whatever my, let's say, a subset is, to be the amount of features available for my, let's say, for my decision tree to actually be able to choose from. There we go. That was the hardest thing to phrase. And then I'm gonna go with something like a random_state, which could be anything this time. Okay, random_state. I'm gonna set that to 42. This can be anything. Basically, what random_state here is gonna do is that every time I run my program, my output is going to be reproducible. I'm going to be getting the same exact output again and again. Okay, I think that's pretty much it, right? I'm gonna go ahead and grab Claude up here again. First, I'm gonna copy this, because I just realized I need to just replace that stuff here. There we go. And then let's send it. Okay, two things to fix before we even get to .predict. Catch them with me. First, the class name you wrote random tree classifier. Was it random decision classifier? Check back what I gave you earlier. It's not random tree. What was the actual name I showed you? This is... this will also throw an import error. Okay. If you try to run it, since that class doesn't exist in Scikit-Learn.ensemble. Decision tree classifier. Second, predict. You've done this exact motion before with decision tree classifier. Look at your own old code. You just pasted above. You wrote model.predict. 190 there. What does .predict actually need as input? A single number or something shaped like X rows. Look at X. Okay. It would need something shaped like X rows. There we go. By the way, JetBrain Island dark theme versus Visual Studio Code is overpowered. I see. So, okay, what is this? Why gaming? Why not workout breaks? Okay, I did want workout breaks, but by God, the only thing I can do right now is, let's say, my hand rippers. I mean, I could move my camera outside. I'm just trying to avoid saying that I'm really lazy to do workout streams, but I need to work out. Guys, I'm getting so scrawny these days. Maybe, you know what? Maybe I'm actually going to be having workout breaks actually, rather than just Wuthering Wave breaks. That said, I like the JetBrains' font. Am I using the JetBrains' font or something like that? Okay, right, predict. Go ahead, rewrite the full block. Alright. So for my entire block, I'm gonna go ahead and reproduce a value. So I'm gonna go with a list of list, where I'm gonna go with 1 and let's say 56. And then we're going to fix our random tree classifier, because I don't really... I forgot what was it called. For random forest classifier. And then I'm gonna copy that and paste it here. There we go. And then we're gonna hit Control S to save the code. Now, if I were to tab Control / to grab my terminal here and change my directory to, let's say, something like Scikit-Learn, and then I would run my command. So I'm gonna go with something like py random. I need to make a tiny change here real quick. Hold on. Random forest. Forest. There we go. Oh, I could have just copied that. I'm such an idiot. Random forest. Forest. CLASSIFIER.py. And then if I were to go ahead and run it, I'm gonna give it a quick little second. JetBrains Mono, best for readability in my opinion. I may try it in that case. Wait a minute, nothing. Oh, my bad. I'm gonna print my prediction. Okay, and that's time. Hands off anything that is not distracting. Moving on back to Wuthering Wave. We're gonna continue this after our break. I'm gonna run it after the break. Oops. I'm gonna get my timer down here. Okay, so it says drag slowly to the left or right, following the arrow. Left or right? I'm gonna go to the right. Oh, following the arrow. Wait. What's happening? Oh, there we go. Okay, okay.
The greedy lose everything in the end. Always.
Yes. Unless, of course.
I'm gonna try to decrease the size. Drag slowly to the right.
We happen to have a trump card powerful enough to flip the table entirely.
Interesting. Drag downwards. Wait, aren't I dragging downwards? Oh, there. Is that Rover? Alright, what's going on? I'm gonna hydrate my chapped lips.
The magistrate of Jinzhou told me what happened on Mount Firmament. If it weren't for him, things would have ended exactly as you said. You're right. I am greedy. Greedy enough to want to keep everyone safe. Greedy enough to dream of an ending where no one bleeds.
Hey, why in the genuine world did these cutscenes give me the goosebumps? Is that Rover? Do you like Marvel movies? I hardly watch any movies, to be honest. I need to start watching them. I mostly watch animes. That too, not anime
And
movies.
I believe that person can carry the weight of that greed. You should know that better than anyone, Sentinel Shin.
Don't you guys feel this in your spine or something? It's so weak.
I understand that perhaps under your current circumstances, you can't tell me the truth. But I want you to take a chance with me. One bet A bet on a future you've never dared to imagine.
Never dared to imagine. Oh?
Honeyed words, sweet promises. How many souls have you sold such pretty illusions to?
Well, I admit
does-
I've never tried them on a sentinel before.
She did give me manipulator vibe from the very beginning. That's one reason I like this character. She's trying to convince me to now summon for her instead of saving up for Hiyuki when she comes. Or was that her name, the samurai one? But I'm still gonna wait for either Zani, Hiyuki, maybe Susu as well, but I need to see about that.
Silver-tongued little thing indeed. I find I do not entirely dislike it. I see. So the Arbiter has come here as well. But at this moment, the one standing before me to make this deal is not him. It is you. If you wish to convince me, then let us place our bets.
I love her fan.
One round. Winner takes all.
Oh, winner takes all. Wait, please tell me there's no cutscene. Please tell me there's no cutscene. There's a cutscene. 30 seconds. Can I stall? Can I stall? Oh god. This is so peak. Alright. I'm not gonna touch squat here. I've got 15 seconds. I'm gonna eat some oats and just chill here. I'm gonna continue this next break. That's it. Time's up. Time's up. Hands off anything that is distracting. Moving on. Back to work. Back to work. Okay, very more specifically, my work here was going to Visual Studio Code and kind of running this program again. So I'm gonna go with py random forest classifier.py, paste it here, and then let's go ahead and run it. So I get a prediction of 0. I wonder why. Okay, let's go with Control C, paste this here, and then say output. I'm gonna go down here. I'm just excited for JoJo Steel Ball Run episode 2. Wait, is that like a new anime, or is that... When you said JoJo, it reminded me of like JoJo's Bizarre Adventures, which I did kind of watch, but I did not really complete the whole thing. But is it like something similar or like completely different? For British or completely different? That said, wait, is that even an anime or like something else, like a show? That said, both fixes landed. Correct class, correct predict shape, and it actually ran cleanly. That's real syntax now. Not just theory. Output is a list of 0 for 1 by 56. Sunny 56 degrees Celsius. Let's check that against your training data instead of just accepting it. Look back at your Y labels next to X. 175, 1 is too hot, sunny outcome. 0, 60. 0, 150, 0. Sunny but cold, not sunny outcome. 0, 40, 0, 181. Question. Does 0 for 156 make sense to you? Yeah, because 0 is for... What was 0 for? Hold up. 0 is for rainy. Rainy is mostly when we stay at home. However, if I were to change 56 to 88, this should move on to 1 rather than remaining, let's say, 0. Because then 1 means success, right? There we go. Is JoJo's Bizarre Adventure sequelish? Oh, I see. Okay, can't believe there would be 6 months between episodes. Guys, 6 months between episodes, kind of crazy. Season 7, essentially. I stopped at part 4. I see. Okay, I did not know that they were getting another season. That said, specifically, what does the data seem to suggest matter more for the outcome? The 1 equals to sunny flag by itself, or the temperature? The temperature is what matters here. Okay, and it makes sense as well. And then let's just go ahead and send it. But after episode 2, it was supposed to return to a weekly format. Oh, I see, okay. A weekly format would make sense because one episode every 6 months sounds absolutely awful. Exactly right, look at the data sign. Being sunny 1 alone doesn't guarantee outcome 1. 1 by 50 is sunny, but comes out 0. Temperature is doing the real high work. Okay, high temperature 1, low temperature 0, almost regardless of the sunny flag, so 156 sunny, but the cooler side landing on 0 tracks with that pattern. Good grounded check. Instead of just trusting the output blindly, one honest caveat, is that how you pronounce a word? I've never heard that word again. Okay, one honest caveat we're naming out loud. Not to undercut you, but because it matters. 5 rows is a tiny data set. A real random forest needs way more data to actually show its diversity advantage over a single tree. With only 5 rows, bootstrapping does not have much room to create real variety. That's fine for syntax practice today. Just don't judge random forests as real power from this toy example. Okay, wait, hold on. With only 5 rows, bootstrapping doesn't have much room to create real variety. That's fine for syntax practice today. Just don't judge random forest real power from this toy example. Okay, you've now covered start to finish today the full trick number 2 mechanism and payoff what is called random forest, why it's called random forest, not bootstrap forest, what the word split disambiguated from .split, random underscore state, what it actually does and does not do, reproducibility, diversity, the real reason averaging trees beats a single tree. Okay, because of more varieties. Working random forest classifier syntax, correct dot predict shape. Okay, I see. I remember starting Dragon Ball 1986, but haven't watched it maybe a few years. Guys, Dragon Ball and the entire Dragon Ball series is one of my most favorite animes of all time. Matter of fact, that is the only anime where I got a bunch of mangas as well. So I may need to restart watching it. 150 episodes, it would be so worth it. Okay, that's it. That's random forest closed fully, verified against real output. Strong session, specially given you flagged out not being warmed up. Okay, I wasn't warmed up the whole time, of course. Want to keep going to SVMs next, or close out here, and I'll generate you a transfer prompt. Wait, let me say, what are all, let's say, the topics that I am expected to work on in order to complete the Scikit-Learn, and that what subcategories does each category consist of? Question mark. All right, let's see. At least it's not a crazy series like One Piece. Definitely not. One Piece has like a lot of episodes. I completed One Piece, but then I did not watch it for like, let's say, about, I think 5 or 6 months, and they got like a bunch of episodes on. That's it. Here's the full classic machine learning with Scikit-Learn breakdown for your roadmap. Oh wait, shoot. I forgot to charge my lighting here. Did that kind of ruin my lighting because I didn't have it plugged in? Let me go to my OBS. Okay, I think it's good. There we go. Classic machine learning Scikit-Learn. This is the category you're asking about. Regressions, linear logistic regressions done. Linear regressions done. Logistic regressions done. Ridge regressions not started yet. Why did we not start ridge regressions? Classifications, decision tree done. Random forest in progress. Finishing today. SVM not started yet. We've got clustering to work with. K-means. Database scan. Dimensionality reduction, PCA, principal component analysis. That's the full classic machine learning block right after That per the roadmap comes model evaluation, training slash test splits, and cross validation, confusion matrices, precision. Okay, hold on. Let me go here and then say. Hey, hold up, guys. There we go. Then let's send it. Okay, wait. You've seen all like original Z, GT, ZK, and Super. Yeah, every single thing. How about the movies? I've watched all movies as well. I'm pretty sure there's nothing that I did not, because I have been watching it since I was like, I don't know, 9 or something. Okay, that said, I think I'm gonna go ahead and move on to like, let's say a new chat, because I feel like I want to save a few tokens. Hold up, let me just go ahead and move on back there. Yeah, I'm just gonna grab my roadmap here. And yeah, in case you guys are wondering how I actually ask Claude for, go to a new chat without really losing my progress. I send it my roadmap, then I tell it everything that I've previously done in the previous topics. Then I'm just gonna eat some oats. Guys, I overcooked these oats. This is not satisfying to eat at all. The Future Trunks saga was one of the most depressing moments. I did not like it much with the black, but then when I've watched it, it wasn't as boring to me. But then again, whatchamacallit, it still had its own, let's say, what's the right word for it? It still had its own charm to it, where we fought with Goku Black, Zamasu, and then later on, I'm not spoiling anything for you guys, but later on, Zeno comes for the rescue. But that's like a whole different thing. I did not want to be a spoiler. Okay, Rich Regressions versus the SVM. What's next? Explain the trade-off, then I'll decide. Alright. Fair question to ask before committing. Here's the real trade-off. No fluff. Ridge regression is a small patch on something you already know. You've done linear regressions. Ridge is linear regression plus a new idea, a penalty that discourages the model from learning too hard on any one feature to fight overfitting. It's maybe 20 to 30 minutes topic for topic once linear regression is fresh in your mind, which it is. Relatively speaking, since random forests just built on that same regression slash classification foundation, the longer you wait, the more you'll have to rewarm the linear regression internals before Ridge makes sense on top of it. SVMs are a new mental model. Different geometry entirely. Alright. Let's work with Ridge regressions. Okay. Let's work with Ridge regressions. Alright, and then let's go ahead and send it. And when that one divine guy became evil and turned into the sky. The fusion of Goku Black and Zamasu. And then I'm not gonna say how he really turned into the sky, because that's more like a split situation. But I don't want to spoil it for you guys if you guys do want to actually watch it. You guys would have understand what I meant when I said split situation if you guys did watch it. I remember being scared during the Android saga. Okay, I can relate to that. The Android saga was pretty terrifying. That said, good call. Patch it while it's warm, then take on the new terrain. That's the disciplined order, not the lazy one. Before we start, do you know what ridge regression is, or is it a cold name to you? It is a cold name to me because I have, let's say, something like never worked with it. Alright, and then let's just go ahead and send it. While it's sending, I'm going to drink some water because I want to be a little hydrated. Then the unexpected thing happened. Do you mean the unexpected thing with Krillin? Okay, no shame in that. That's exactly why we check first instead of assuming. Let's build it from the ground up. Okay, starting from what you already know, you know linear regressions. Quick recall, not new material. When you ran .fit on linear regressions, what was it actually doing under the hood? What was it trying to find? It was trying to find the gradient descent. Gradient. Did I spell this correct? Gradient. The gradient descent. However, it has been 2 days since I last worked with it. Therefore, let's go with something like therefore. Can you give me a quick refresher? There we go, and then let's just go ahead and send it. And Cell, now the androids become, oh god. Yeah, Cell absorbing them. It did feel kind of weird. Or becoming allies. Cell becoming perfect Cell. That's it, fair, 2 days. Exam gaps happen. Wait, 2 days because I had 2 streams before that. And this is exactly the not warmed up case. Let's do a real recall rep, not just me lecturing at you. Let's refresh it piece by piece. Y equals to mx plus b, the slope formula. Linear regression is trying to draw the best fit line through your data, a line form. Y equals to mx plus b, where m is the slope. Dot coe f underscore and b is the intercept. Is the dot intercept underscore best fit? Means out of every possible line you could draw, find the one where the total error between the line's predictions and the actual real data points is as small as possible. Dot fit is the process that searches for the best MNB. You said gradient descent, and you're not wrong that gradient descent is a way to search for it, but here's the question to sharpen it. Gradient descent is the method for searching. Think of it like walking downhill step by step to find the lowest point. What is it searching for? In other words, what's the lowest point it's walking towards? What quantity is gradient descent trying to minimize? It was quite sad when the Super ended. It actually was, but they're actually getting whatchamacallit, Dragon Ball Super Season 2 with the what was it called? The Galactic Space Saga? Not the saga that comes before the Moro Saga, but I'm not gonna spoil it because I read the manga. That was such a good storyline, it was! Okay, let's see. That fit is the process. Gradient descent is the method of searching. Think of it like walking downhill step by step to find the lowest point. What it is searching for? In other words, what's the lowest point it's walking towards? What quantity is gradient descent trying to minimize? Let's see something like can't recall because I worked with it 2 streams ago. However, let's say something like I just need a refresher in order to let's say answer it. Okay, I just need a refresher here. Out of them, All Kai might have been my favorite storyline. All Kai. Do you mean the one where there were like Boo was Majin Buu was going and killing all the Kais? Is it that one? That's a fair ask. You flagged it honestly instead of guessing blind, which is exactly the right move. Here's the piece you're missing. Gradient descent is minimizing the error, specifically how far off the line's predictions are from the real data points. That error has a name, loss or cost. For linear regression, specifically, the standard loss is the sum of the squared differences between predicted y and actual y. Just making sure that everything is still recording. Okay, it is. There we go. Okay, and bring back feelings of nostalgia, although I never watched it when it was airing. Oh, I see, okay. That said, for linear regression specifically, the standard loss is the sum of the squared differences between predicted y and actual y. Oh, I see. Okay. Squared so that positive and negative errors don't cancel out, and so bigger errors get punished harder than small ones. Alright, I'm gonna go ahead and let's say eat some oats because I think I want to get some of the effects of the cinnamon here. So the full picture, MNB defines a line. For any given MNB, you can measure how wrong that line is. That's the loss. Gradient descent is the walking downhill process that adjusts MNB step by step to make the loss smaller and smaller. It runs that whole process and lands on MNB. That makes the loss as low as possible. That's the full loop. Line, error, loss. Oh, okay. There we go. Okay, we got it. There we go. Got it. I see. And I, let's say, remember, it was the trial and error until it did not land onto the best answer. There we go. Close, but let's tighten up. Trial and error undersells it, and the imperception matters. Your gradient descent isn't blind trial and error, like randomly guessing lines and checking which one's the best. It's directed at every step. It calculates which direction would reduce the loss. That's what the gradient pattern part means. Since a signal pointing toward loss is decreasing this way and it moves in that direction, then it recalculates and moves again step by step, always guided, never random. Think of it like walking downhill in fog. You can see the bottom, you can feel which way the ground slopes under your feet right now, so you can take a step that way, then you feel again. You're not randomly trying spots on the hillside. Every step is informed by the slope right where you're landing. Okay. It stops, lands on the best answer when the slope flattens out. No more downhill directions to move in. That's the loss. Or near its minimum. Does directed, not random, guided by the slope at each step land better than trial and error? So it tries to keep reducing the errors using logical steps until it is in the best position. Okay, I see. That guy was when Goku was significantly older. The famous scene Goku versus Vegeta, it's over 9,000. By Kai, do you mean King Kai? Like he went to King Kai's world to, train to beat the Saiyans? Yes, that's exactly it. Logical steps instead of trial and error. That's the precise fix, and it matters. You've got to keep reducing the errors using logical/directed steps, guided by the slope until you land in the best position, lowest loss. That's your linear regression refresher. Fully rebuilt. Now you're warmed up. Let's build a ridge on top of it. Before I really work on that, I'm gonna drink some water. Oh, it's over 9,000. I get it. His power level. There we go. Actually, I'm gonna take another sip. Do you remember when Majin Buu turned someone into a cookie and ate them? I don't remember. He did turn like multiple things into cookies. Even in what's his name? The after Kai, who is the other Earth's caretaker after Kai? I forgot. Dende, there we go. In Dende's world, he turned everyone. Okay, I'm spoiling a lot of things here. Say you're predicting house prices and you have a feather-like number of bathrooms. Gradient descent finds the M, the coefficient/weight for that feature that minimizes the loss on your training data, the data you already have. Now, imagine gradient descent finds a huge weight for number of bathrooms, way bigger than makes real world sense. Because in your specific training data, houses with more bathrooms happen to correlate really strongly with price, maybe by coincidence or a small sample size. What do you think happens when you feed that model a new house it's never seen before, where that coincidental pattern doesn't hold up? Say you're predicting house prices and you have a feature like number of bathrooms. Gradient descent finds the m, the coefficient slash weight for that feature that minimizes the loss on your training data. Now imagine gradient descent finds a huge weight for a number of bathrooms, way bigger than makes real world sense, because in your specific training data, houses with more bathrooms happen to correlate really strongly with prices, maybe by coincidence or a small sample size. What do you think happens when you feed that model to a new house it's never seen before? Where the coincidental pattern doesn't hold up? Hold on. No, Goku was on Earth in Dende's world. Remember when the evil Majin Buu was waiting in Dende's world for let's say to fight the strong warrior, where he let's say turned Android 18 and like everyone else into like candies and ate them up, including Chi-Chi. No, I think Chi-Chi was an egg. Oh god, guys, I did not want to talk about this on stream because I don't know if anyone's actually gonna watch it and I'm spoiling it for them. That said, okay, I'm gonna let's think. What happens? It starts to evaluate using the wrong data. That's it. Time's up. Hands up anything that is not distracting. I'm gonna move on to Wuthering Waves as soon as I send this. It starts to evaluate using the wrong data from a previous house. There we go. Okay, moving on to Wuthering Waves. There we go. So this is where we were about to, let's say, fight the Sentinel. I'm gonna get my timer here. I want to be as prepared as I can. I missed these. Guys, the animation is sick. An elegant pose. You're falling? This reminds me of the Demon Slayer Infinity Castle movie.
So be it. A bet is a bet. I yield my ally. No. Soy.
Oh.
For now, I place my hope in your hands.
She won! Why does it always run a shiver down my spine? I get goose freaking bumps whenever I see a cutscene. I can't wait for the Wuthering Waves anime. I think they're collabing with Sword Art Online as well. Oh, dark screen. But was that it? I wanted the cutscene to be longer. I would have been done with it. With my last in my last break.
That direction.
Is that an earthquake? Earthquake.
Dumpling?
Or no?
It's your time to shine. I'll treat you to as many plates of dumplings as you wish. So...
Does Dumpling really eat dumplings? I'll treat you to however
I'm counting on you.
Counting on you. Is Dumpling taking that to Rover or no? Oh wait. Oh wow, please select a line. Here's the thing, your choice only allows you to experience these stories in different order and does not affect the narrative context. I'm done with Susu's line. I need to go with Rower's line now. Can I really go with... Nope, I need to go with Rower's line. Alright. And then we're just gonna exit. Quest rewards.
Conception.
Conception. Okay, so inspect the Sky Crib armory? Armory, I think that's what it is. Do I activate this? Continue with Rower's path. Oh. Wait a damn minute. Do I need to activate this? Healing complete. Alright, we're on with Rover. Oh. Is that like mana crystals or something? Alright. So I can switch maps, but I will not switch maps. Rather, I want to continue with Rower's path. I don't know how. There we go. Oh, there we go. I didn't see that because of my timer. Oh, I'm gonna get this here. Are you kidding me? Let me just get this not long ago.
The frequency trace ends northwest of the Eastern Shuan Peaks. Either it's heading somewhere a Skywatch ring cannot monitor, or...
Oh yeah, been a while since I spoke with Liang Yu.
Wait, there's something on the back of this letter. These marks. Were they left by the streams? Skyworks.
Skyworks? Yang Yang actually mentioned that place?
What is it?
A factory in the Western Fong Peaks. It's where Xuanfang Hold produces its auto puppets and disposes of tacit discords.
I see.
The Ministry of War just flagged it. They say the Skyworks has become a hive for rogue auto puppets. Even the Xuanfang wardens in the Ministry of Development can't get close anymore.
Interesting.
You think Yang Yang went there?
She went out of her way to leave us
Matter
this
of fact,
message.
she did.
I can't ignore it.
Okay, I'm currently playing this through the point of view of Rover, so I'm gonna pretend I don't know it, and I'm trying to find clues.
What about you?
I don't really know
What's
it.
your move?
The hold is under siege from all sides. My commander's order was to reach Jinzhou through Shaft Post Yard's mountain gate, to call for reinforcements. But the gate is sealed. There's no other way out. If I do nothing, I'll just be waiting for death.
I see.
I'm coming with you. If Yang Yang went to the Skyworks, she must have sent something important. Besides, I owe her a great debt.
I'm pretty sure she
Only
did.
The Skyworks has become a den of horrors. 2 souls alone may not be enough.
We'll just have to find out.
Right.
As you can tell, I'm a
You mentioned
super
earlier
fan
that the
of
Sentinel
Dragon Ball
Ninja was
2. That
missing.
actually sounds really cool.
Well,
Yeah, you mentioned.
she holds a residence in Xuanfang Hold, but the doors have not opened in a long time.
Okay, so
The warden
leave the
commander tried to contact
Shaft
her
Post
many
Yard.
times, but received no response.
Oh,
Missing
let's
too many
go.
pieces of the puzzle at this point in time.
Agreed.
Oh,
Let's hope we find some clues at the Skyworks.
yo, that. You know, whoa, wait, whoa. I did not know that I
was
could
wondering,
use this motorbike
Did you
like
come
that.
here alone?
What the hell?
No. I had a companion. We got separated before I ran into
Wait,
you.
Was it because
went
of the
in the wrong
disorienting
direction.
fog? Aren't you worried about her?
I am. But we agreed we'd stick to our own goals unless things
Wait,
got
I can
really
fly?
bad.
Is it like
She
a
knows what
craft?
she's
Wait,
doing.
hold on.
This fog won't stop her.
Is that so? Then we should pick
This
up the
is
pace
really,
too.
really good. Okay, I'm trying to leave this place. Hello? Oh, this is a bad idea, I think. How do you... This is super fast, but it's so freaking hard to... I got further away. Okay, let's try not accelerating. Oh my. Who let me drive? Who gave me a freaking license to drive this motorbike? There we go. There. Slow and steady wins the race. Oh god, no. Nope. Oh my. You know what? Screw it. I'm just gonna run. I didn't even need a motorbike. I'd rather burn some calories. I also really want to watch Cyberpunk. Edgar Runners, is that how you pronounce it? There's also that new Avatar cartoon coming out. Oh, I see. Damn, I really wanted to. There we go. Oh, I see. Wait, I want to go lower. I want to get out. Whoa. I want to really master riding this stuff. This is the fastest.
Someone fought an entire squad of auto puppets here.
The traces on the remains. It was Yang Yang.
Really?
It was her.
Then we should be able to track the frequency she left behind.
Hang on, Yang Yang. I'm almost there.
Inspect the auto puppet wreck. There. Dismount before interacting. Alright. Gonna eat some oats real quick.
These auto puppet kernels. Abby.
Wait, I just remembered that Yang Yang was ambushed by auto puppets. Hey, want some snacks? Do you think it looks like a giant piece of candy? I'll go with want some snacks.
No, absolutely not. It looks nasty. Ugh.
Looks nasty. Ugh. So what have you covered so far? In Wuthering
My
Waves
stomach
or...
isn't a
Oh wait,
trash
machine
can.
learning stuff. Hold up, I'll say that like after 4 minutes, as soon as this is over. Okay, this may help us locate Yang Yang. You can analyze its frequencies. Go with the first one.
Fine. If you say so,
Fine.
I'll do
You
it.
say so. I'll do it.
It's all for Yang Yang, okay? Even if I get a stomachache, I'll still do it.
Alright.
What did you
Wait, he said that
taste?
tasted awful, my bad.
Well, I'm not sure how to put it. The frequency was messy, like a billion math formulas all tangled together. Looking at it makes my head hurt.
What if the core program... What if it's the core programming driving the auto puppets? Oh, interesting. Yeah, and?
It's weird. On top of that string of numbers, there's a ton of emotions. Rage, regret, disappointment.
A machine isn't supposed to have emotions.
For the time being,
Could
it's
that be
not.
what's causing them to go rogue?
Too much bad juju.
Isn't that
My
you?
stomach's feeling all kinds of wrong. I'm out. Gotta crash for a bit. Wake me if something goes down.
Were those
All
emotions
right.
implanted? Or
Sorry, but What was that thing back there?
Continue forward.
You mean Abby? That's my echo. It has a big appetite.
I guess I better not pry.
Don't do it. I want to really master this thing. Wait, what if
For an auto puppet kernel to possess emotions, the fighting stretched all the way here. Yang. She did this alone.
defeat the remaining auto puppet?
These things aren't dead yet.
Oh wow! Oh, I'm freaking ambushed. I want to move the other one. I want to use the other one. I can't use my companion. No. Rover has the most basic. Wait. Is it just me or did Rover's skill sets increase? I mean, the way he attacks it changed.
One with the sounds.
Damn, that combo is nasty. Wait, I want to use his ultimate. His HP is pretty low. Alright.
Are you alright? Leave it to me.
I'm fine. Just been overusing my forte the last few days. I'm a little tired.
What's his ultimate?
You, on the other hand, you look like you've barely broken a sweat.
Let's just say I got plenty of practice against humanoid weapons back in the High Lord.
Okay, I didn't really like his ultimate, but it's basically just I'm basically button mashing, so I wouldn't really know either.
What kind of life have you lived?
I love the combo here. Oh, the combo takes a lot of stamina. That's the downside. Alright. Millions of math formula.
Someone treated the wounds here. It must be Yang Ying. She's injured.
Oh?
It must not have been too serious. She doesn't appear to have stayed long. How many auto puppets did she fight? They do attack humans sometimes, but she doesn't seem like the type to provoke them.
She must have found something. Maybe the source of the auto puppet rebellion.
These treks.
Oh wait, shoot, okay. Hands off anything that is distracting. Hands off anything that is distracting. Back to work, back to work. My freaking timer was so small that I didn't even realize that the timer ended 30 seconds ago. Alright, okay, now the question. With machine learning, how much did I actually cover and how far I'm in my, whatchamacallit, series? Let me grab my roadmap real quick. So basically, I'm currently in phase 2, which covers, let's say, math and machine learning, where I am done with the category of applied math and all the subcategories inside of it. I'm currently under the classic machine learning, which is Scikit-Learn, where I'm gonna be, let's say, where I have worked with regression, linear, and logistic. I'm working with Ridge so far. But when it comes to classifications, I did work with decision trees and random forest. I clearly don't know why Claude skipped over Ridge regression and moved on to classification, but I think there probably would have been a reason. That's it. The remaining topics for me to cover right now is Ridge regressions, SVMs, K-means, database scan, and PCA, which I kind of forgot what it means, which is basically dimensionality reduction, and clustering, which is the database scan and K-means. After I'm done with that, I'm going to be moving on to the model evaluations category, which I am kind of excited for, to be honest. And then we're going to be having a mini project before I move on to phase 3, that is deep learning and neural architectures. That's it. That was pretty much it for that. Do name game. It's actually Wuthering Waves, or WUWA as well, WUWA, or WUTHERING, and then WAVES. It is a pretty good gacha game. That said, it takes a lot of space. That's one downside to it. That said, not quite. Let's slow down on this one because the mechanism matters. I asked a question asking it starts to evaluate using wrong data from a previous house. Okay, that was a random guess that I gave it because it asked me a question that what happens when you feed that model a new house it's never seen before, where that coincidental pattern doesn't hold up. So basically, what happens if I have a trained model, which is trained specifically to evaluate the, let's say, cost for a certain house based on its square feet, based on its weights, and I grab that exact same model and give it in a whole different, let's say, house, mansion, hut, whatever thing it is. How is it gonna, let's say, evaluate that? I gave a guess saying that it's going to evaluate using the wrong data that it had. Because again, that was just supposed to be a random guess. Scikit is just a Python library used for machine learning models. I see. Okay, and give me a sec. I'm gonna drink some water. I'm getting real dehydrated out here. Okay, not quite. Let's slow down on this one. Because the mechanism matters that model isn't looking at the previous house at all. When it predicts a new house, it's not comparing new data to old data directly. Here's what's actually happening. .fit already ran and now it's done. It locked in a specific M weight for a number of bathrooms. Let's say it landed on M equals to 50,000. Already ran it and now it's done. It's locked into a specific M weights for a number of bathroom. Let's say it landed on 50,000, meaning each bathroom adds 50,000 to the predicted price. Because that pattern fits the training data well, now a new house comes in. The model doesn't look back at all houses, it just plugs the new house's bathroom count into that same locked in formula. Price equals to 50,000 multiplied by bathrooms plus ... Okay. If that 50,000 was too extreme, inflated by some coincidence in the training data, not a real stable pattern, then the new house's prediction will be widely off, not because the model is just using old data wrong, but because it's applying an overconfident, exaggerated weight to new data where that exaggeration doesn't hold up. Why did you want to play Wuthering Waves? Actually, I did start off by playing Genshin Impact, but it was too, let's say, pay to win. That's why I moved on to Wuthering Waves, because it is mostly free to play, besides a few things. If you want, you could purchase and like get better skins and all that stuff. That's the reason I mostly went with Wuthering Waves, was because it was a gacha game for starters, and it has like a lot of story which won't really get over, let's say, as fast, as opposed to playing Valorant, which every match, let's say, takes about 40 minutes. That is way too long for me to play. Plus, also, if I did play, let's say, Swift Play, I still wouldn't make it in time for the 5 minutes mark, if that made any sense. So this was the best alternative to them, and it's also pretty fun, to be honest. If that 50,000 was too extreme, inflated by some coincidence in the training data, not a real stable pattern, then the new house prediction will be widely off, not because the model is using old data wrong, but because it's applying an overconfident, exaggerated weight to new data where that exaggeration doesn't hold up. This has a name you may have heard before, even outside machine learning. When a model fits its training data too well, including the noise and coincidences, not just the real pattern, and then performs poorly on new data. What is it called? Inaccuracy? Also, can I get a different real world example? Okay, then I'm gonna go ahead and send it. Also, may I ask why you want to get into AI engineering? Because I always like the idea of, let's say, okay, I would mostly say robots, but then not specifically robots, because I don't want to go with the mechanics and like I don't want to like literally make the robots that like, let's say, a robotics engineer would do. Instead, I wanted to work on the brains of AI, so I thought if I was an AI engineer, I would have engineered the AI. But here was a downside. The more I work with AI engineering, the more I start to realize that AI engineering is not about working on the AI's brain or training an AI. It's more about using the models from a machine learning engineer and implementing those models into websites, softwares, apps, etc. But that was one reason why I thought that I should probably switch up to machine learning engineer. Maybe once I'm done with my AI engineering for 365 days a series, Spoilers alert, I may have, let's say, another series which could be 500 days. That is just a guess. I may change it depending on what I really want to work with, and I may try working as or learning the contents to be a machine learning engineer as well. At the end of all those series, whichever thing I liked, I'll probably be that. Luckily for me, I'm way too young. I got all the time in the world to spend. That said, a good instinct flagging that. I would say most of you guys do got a lot of time as well, to be honest. That said, good instinct flagging that inaccuracy felt off. It's too generic, and asking for a different example instead of forcing a guess is exactly a right move. The actual term is overfitting. Oh, I do. Okay, I did work with that. I just did not remember it. You've hit this word before. Oh yeah, it stuffs up a lot of let's say data. I should probably add the word called cognitive lockdown as well. Is that what AIs go through? Back in decision trees, why a single tree isn't trustworthy alone? Same core idea here. The model memorized quirks specific to the training data instead of learning the real generalizable pattern. Is that how you pronounce it? So it performs great on data it's already seen and poorly on new data. Oh yeah, that does make sense because it already has assumptions based on the content that it did already work with. Fresh real world example, no houses this time. Imagine a teacher who only ever studies exact 20 practice questions in a review packet, memorizes the exact answers to each one. Instead of understanding the underlying math concept, on the practice package, perfect score looks like a genius. Instead of understanding the underlying math concept, on the practice package, perfect score looks like a genius. Then the real exam comes with 20 new questions testing the same concepts, just worded differently or with different numbers. What happens to that student's exam scores and why? It decreases because it did not, because they did not understand the concept. Rather, hold up, there we go. Rather, they went with what they had already memorized. There we go. They lacked the ability to assess the situation. Okay, that said, okay, let me go with something like, that said, does that mean, overfitting could also be, I don't know, could also, there we go, be classified as a, how do you spell cognitive? Cognitive. Lockdown? Interesting. Hold on, let me just fix my typo and then let's go ahead and send it. I'm 21. Oh, we're not that, our age, okay, you're just like 3 years older than me in that case. Don't know if I want to become an AI engineer is overkill for what I want to do. Don't know if becoming an AI engineer is an overkill for what I want to do. What do you want to do? One of the projects I want to do is create a desktop assistant. Okay, I think that being an AI engineer for that is not really going to be an overkill because an AI engineer is what actually could add or augment that assistant into the desktop. But the model would have to come from a pre-existing or a pre-trained model, or the assistant specifically would be a trained model or a model, should I say custom made by, let's say, a machine learning engineer. But by God, machine learning engineering or machine learning takes way too much math. My brain cannot comprehend that. Maybe later it will. As I realized, Google has their own assistant, but it's not compatible with Windows. Oh, I did not really know that. What kind of assistant does Google have? That's a solid explanation of the student example. That's exactly right. Memorized answers over concept, and it collapses on anything new. On cognitive lockdown, I get why you're reaching for that phrase, but I want to redirect you off it rather than let it stick. Because it'll actively confuse you later. Overfitting is the same model getting stuck or locked. It's the opposite problem. The model was too flexible, too willing, let's say, to bend and twist itself to match every little bump and coincidence in the training data. It's over-adapted and not under-adapted. Lockdown implies rigidity. Overfitting is actually excess flexibility. Oh, I see. Okay. The cleaner mental tag, overfitting equals to memorized instead of learned. Fit the noises. Okay, why did I just get an error saying Unreal Engine 4 client game has crashed and will something? I don't even have Unreal Engine running. What the hell? Was Wuthering Waves made in Unreal Engine 4? Huh. Like Siri, you know? Oh, I see. Okay. Okay, let's see. Wait, I did not know that Wuthering Waves was made in Unreal Engine 4. I thought it was Unreal Engine 5. Okay. Opens program, you can ask questions and it answers, etc. Oh, I see. Okay, that's it. Now, back to the actual model mechanics. Trying it to your bathroom example. Overfitting in linear regression tends to show up as coefficients. Overfitting in regressions tend to show up as coefficients, the m values that are too large / extreme. The model swinging hard on one feature becomes because it happens to look powerful in the training data. So here's the real question. Ridge regression answers. There we go. Ridge regression answers if large extreme weights are symptoms of overfitting. What do you think Ridge does structurally? Try to prevent that. There we go. I'm gonna get this here. Unreal Engine Slop XD. Unreal Engine is the whatchamacallit, the production level game engine that people really use. Opens program, you can ask questions and answers. Okay, that said, okay, I think I'm reaching my cognitive lockdown. Way too much information today. I think I'm gonna probably just call it a day. After this 9 minutes is over though. Okay, let's see. Okay, on cognitive lockdown, I get why you're reaching for that phrase, but I want to redirect you off it rather than let it stick because it'll actively confuse you later. Overfitting isn't the model getting stuck or locked, it's the opposite problem. The model was too flexible, too willing to bend and twist itself to match every little bump and coincidence in the training data. It's over-adapted, not under-adapted. Lockdown implies rigidity. Overfitting is actually excess flexibility. Wait, let me say something like, I still do not understand. What do you mean? Okay, I don't understand because I've been working with this for a long time and then I'm kind of exhausted right now. I'm just waiting for my timer to end. That's it, good you said. So directly instead of faking it, I'm gonna try locking in for these last 8 minutes. Must there's a lot of AAA games developed in Unreal Engine that are optimized as frick. I see. Okay, good, you said. So directly, okay, let's rebuild it. Here's the core concept stripped down. Normal linear regressions is .fit has one job. Make the loss error on training data. Make the loss as small as possible. Okay, that makes sense. That's it. Nothing else matters to it. If it makes one weight huge, shrinks the training error even a tiny bit. If making one weight huge shrinks the training error even a tiny bit, even from a coincidence. It'll do it. No pushback, no restraints. Ridge regressions gives .fix a second job added on to the first one. Now .fit has to balance two things at once. Still try to make the loss small, fit the data well. Also try to keep the weights, the M values, small, not huge. Oh, I see. Okay. It's like telling gradient descent, yes, minimize the error, but you're not allowed to do it by blowing up any one weight to a crazy size. Keep the weights modest too. So if there are two possible lines that both fit training data almost equally well, one using a huge weight on bathrooms and one using a smaller, more modest weight, Ridge will prefer the smaller weight line even if it got a tiny bit more training error because extreme weights are a red flag for overfitting. Interest. I see. Question to check if this landed. If Ridge is telling .fit keep weight small too, what do you think happens to a feature that's just noise/coincidence, like a weak, unreliable pattern, versus a feature that's genuinely strong in predictor and a real predictor? Let's see. If Ridge is telling Fit to keep weight small, what do you think happens to a feature that's just noise/coincidence, like weak, unreliable pattern, versus a feature that's genuinely strong? It would avoid that. Okay, let's see. So it would avoid that. However, I had a question. Why is huge weights a red flag, question mark? And why? Let's go with a comma real quick. And why do what does weights mean? Is it a term used universally or just for me to understand? There we go. Okay, and then we're just gonna go ahead and send it. Okay, both great questions. Let's nail them down before going further. What does weight mean? Weight is a real universal machine learning term, okay? Not something I invented for you. It's actually the same thing as M. The slope, right? The coefficient. Okay, wait, M is the coefficient. The coefficient from linear regressions, you already know it under a different name. Price equals to M multiplied by bathrooms plus B. That M is the number that says how does this feature matter and in what direction gets called the weight. Once you're talking about it more generally, specifically once you have multiple features, if you have 5 features, if you have 5 weights, one per feature, each one saying how much should this particular feature push the prediction up or down, same concept as .coef underscore, just more general/universal name for it across all of machine learning, not just linear regressions. Why is a huge weight a red flag? Think about what a huge weight actually claims. If M equals to 50,000 for bathrooms, the model is saying I am extremely aggressive. I'm extremely aggressively confident that every single additional bathroom adds exactly $50,000. No exceptions, no nuances. Well, nuance, not nuances, plural and singular. That's a bold extreme claim. Real stable patterns in the world are usually moderate. A bathroom probably does add value, but rarely in some huge, dominant, overwhelming way compared to everything else. Location, square footage, etc. When .fit lands on a huge weight, it's usually not because reality is that extreme. It's because the model found a shortcut, some quirky coincidence in this particular training data that let it reduce error by learning hard on one feature, rather than actually learning the balanced real-world relationship. So, huge weight usually means the model got overconfident based on a coincidence. Not this feature is genuinely that powerful. Does that clear up both pieces? Okay, you know what? I did understand it, but I think I will be continuing the rest later on because I understood it, but I keep forgetting it after I'm done reading. Okay, let's see. Wait, let me say something like, let's say I feel like I did understand. I did understand it, let's say when I read it. However, wait, I think a semicolon would make more sense than a comma. However, as soon as I was done, let's say, reading it, I forgot. Let's go with something like I forgot all about it. Okay, most likely because I am at my, let's say something like limit. Okay, therefore we can continue the rest next stream alongside, okay, let's say something like alongside a real explanation on the ridge regressions is topic as well. Okay, hold on, I'm gonna fix a few typos. Alongside a real explanation on the ridge regressions is topic. Okay, and then I'm gonna go ahead and send it. And that said, that's time. Hands off anything that is
serious. She doesn't appear to have stayed long.
Hands off anything that is not distracting. Moving on back to Wuthering Waves, probably gonna be my last break. It must have not been too serious. She didn't appear to have stayed long. Alright.
How many auto puppets did she fight? They do attack humans sometimes, but she doesn't seem like the type to provoke them.
Did I watch this part? I forgot.
She must have found something. Maybe the source of the Auto Puppet Rebellion.
These treks. It's a cloud ride. She took one to the Skyworks.
Cloud ride was the thing that I kind of stopped on, but I didn't ever use it.
Let's keep moving.
Alright. Oh wow, let's go. I love this motorbike. Head to the Skyworks 533 meters away. I'm gonna get there in a sec.
The wind.
Oop, I was getting distracted. What does E do?
She left it for us.
Oh wow, guys, this is awesome as hell. Okay, having this motorbike is such a life/time saver. Ooh. Are they meteoroids? Are they... What the hell? Are they cannons, bombs, bullets? Projectiles? Oh. Did she jump off? Revive?
This is Yang Yang's cloud ride.
Oh, they were showing us what already happened.
But where is she?
Okay, I thought that was happening like right now. Wait, that's her? Is that her hat?
This is Yang Yang's.
It is her hat. He's trembling. Shivers.
How unexpected. Uninvited guests at a time like this. Let me guess. It was that foolish girl's rafter kite that led you here.
Who are?
A watcher who slipped the net. It seems I miscalculated the Paragon's capabilities.
You.
You.
Where's Yang Yang?
Yang Yang. So that is her name.
Answer me. I wouldn't ask twice. You know what? What would I go with if I was Rover? I wanna have some action, so I'm gonna go with something like I won't ask twice. Ooh.
A shame, really. She could have contributed to my grand experiment. Instead, she chose the path of self-destruction.
Instead, she chose the path of self-destruction.
Interesting.
Interesting.
Black hair, golden eyes.
Golden eyes.
You match the description given by the woman in red.
You match the description given by the woman in red.
Such a shame.
What a
you
shame.
fancy yourself a hero, but you're too late. Far too late.
Far too late. I thought he started.
The experiment is nearing its final stage. Soon, Zhuanfang
Wait.
Hold, this little toy box in the center, will finally realize its true value.
What in the genuine world is happening to him? This reminds me of Yinlin's ability.
Come on.
Alright.
What else can we use?
Find another way to the Skyworks.
That man. He's the mastermind behind the Autopuppet Rebellion?
Hurry! We can't let him get away!
End of a day living a fully life or a delusional of it is more than what most can achieve. A fulfilling life or a delusion of it. Huh. It actually does make sense. Okay, that's... There we go. Okay, I'm so glad I jumped off. Wait, I should have used my freaking raptor. Oh yeah. Let's go. How do I go higher? I'm lost. Oh god, oh god, oh god. No, 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 no. Oh. Alright, I can't see squat. Just gonna jump. I'm gonna fall, right? I'm gonna fall, aren't I? Nope, I'm gonna fall. I'm sleepy. Good night, Viv. Honestly, I appreciate you joining the stream, Observer. I'll catch you next stream. That's it. Make sure you get your 8 hours of sleep as well. How do I left my quest area? How do I go there? Optional, use zipline. I want to use my zipline. Alright. That's... Okay, this is perfect. Take care.
Just
Take care
now.
as well.
He spoke like he knew you. Have you met him before?
Oh, wait. There we go. That's time,
No,
actually.
I don't think so.
Hold on. Oh, wow. He can exit it. Okay.
Did he mean a Firaxidus Overseer?
There we go. Alright, okay, you know what? I think that's pretty much it. That's time as well. Hands are, you know what? I'm pretty much ending my timer here. Let's go with pause and then I'm gonna exit that. And I am gonna be continuing this next stream as well. That said, I'm gonna go to my OBS and let's say move on to my main camera. There we go. Alrighty guys, so basically that was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash that like button, subscribe and notifications turn on. And if you guys did enjoy my content slash streams or my videos in general, make sure to share my channel because like helps my algorithm sharing, makes you smile, and subscribe link at here on top. That said, I did stop multi-streaming because it did affect my streams' quality. That's it. If I did find a way to multi-stream simultaneously across several platforms without it reducing the streams' quality, I will try multi-streaming, but for the time being, I am not multi-streaming. And if you guys do want to follow me in, let's say, all my socials, you guys can get access to all my socials actually in general through the link in, let's say through the link in my description. Hold on, let me show it to you guys because apparently that's what really makes it easy for you guys to know it up. There we go. Okay, so you guys can get access to all my socials through the link in the description of my stream here. You guys can get access right here, there we go. Through my bio, which I just showed you guys, like, let's say, a couple of seconds ago. Or by typing exclamation and the name of the social on chat. For example, I could go with exclamation, I don't know, Instagram. There we go, all lowercase, no space. This is going to be popping up a link within 3 or 4 seconds. If the social does not exist, a link will not pop up. That said, let me go back to my main camera. There we go. And also, I did create 2 brand new channels, one called Viv Arcade, the other called Viv Workshop. Viv Arcade is specifically meant for my gaming content, the other Viv Workshop is meant specifically for my workout content. Therefore, if you guys are interested in either one of those categories or genres and that you guys want to check those channels out, again, you guys can get access to, let's say, those channels. Let me go back to my gameplay screen, and there's a ant in my wall. You guys can get access to both my channels through the homepage. If you guys scroll all the way down, there will be I will be having both my channels featured here, Viv Arcade. I do upload daily videos on Wuthering Waves here based on my streams and Viv Workshop, which I highly doubt you guys should actually follow because I haven't uploaded it in a while. Last video was basically my last live stream a month ago, which I will start uploading there as well. That's it. If you guys do enjoy either one of those contents, you guys could follow me there. And also, my stream is broken, I'm tired of asking your name. Okay, you know what? I'll give you a slack. Ask me for the next 10 streams and I'll type it out. That said, just tell me no. Tell me if I know I'm late. Stop ignoring me. I actually wasn't ignoring. That said, whatchamacallit, what else was I gonna say? And yeah, if you guys do want to follow me in my AI Engineering for 365 Days series, and that you guys want access to the roadmap that I am currently using for this series, you guys can get access to my roadmap through my Discord server. Let's say either by going to the Coding Helps Us chat, Python chat, or the general chat, mentioning my name there at VivUniverse, asking me for the roadmap. I will be personally DMing it to you guys as soon as the stream is over. That's it. You guys can get access to my Discord server through the link in the description, through my bio, or by typing !Discord on chat. We are close to 200 members as well, so I'm pretty sure I won't be doing anything special once we hit 200 members, but I think that's pretty much it for the stream. That said, I'll catch you guys in the live stream or video. Peace. Okay, I guess let's end it.